So Jim, what are we going to talk about today?
Multivariate analysis.
Okay, so for all of us that aren't, data nerds and just normal geniuses, can you tell the rest of the world what multivariate analysis is so we can save about 50,000 people from going to Google?
I chuckle because I'm hardly a genius. Fortunately, this stuff makes me look really good. So multivariate analysis is a lot of the algorithms that happen to be in it, which the ones that typically you'll see are principal component analysis, or PCA, partial least squares, or PLS. Let's see, there's probably one other one, but those are two of the main algorithms you'll see. They're kind of grouped in that machine learning, bucket, right? They're like a little section of machine learning. There's a whole bunch of other algorithms out there. But multivariate analysis, that's easy for me to say, really is kind of geared, I think, really well at the process industries. It seems to find relationships, especially in kind of linear processes. And really what it does, I mean, if you look at that screen, each one of those dots represents basically a product genealogy. It's a batch in one process, a batch in another process, and then some continuous data, all that one particular starting batch went through, right? Through several hours worth of things. Summed up mathematically in a three-dimensional space. It's a dot. So if you think about it, if I sum up mathematically all the data in one batch run, I'll have a dot somewhere in space. If I run really close to the same, I'll have another dot pretty close to it, but not exactly on it. If I run very differently, that dot's going to be very far away. There's going to be something mathematically that drives it, in an opposite direction. And so with that, then you can start to understand, well, what are those variables that drive it away? And you can even classify things like, hey, maybe this was a good run, this wasn't a good run. And so you can really kind of understand your process. And what I always tell people, you can eliminate ground. You can throw a bunch of variables at it, ask some very specific questions. Don't think you're just going to go, oh, I'm just going to throw a bunch of stuff against the wall and just, this is going to tell me everything that I've ever done wrong in my process. That's not the way this works. And it's not a silver bullet, but it helps you eliminate ground, and it really tells you, well, what's different? What changed over time, or what's different between this batch and that batch that I ran, and this one's good, this one wasn't. What was different? And where it's not obvious.
Okay. So we've got a bunch of data. We want to run it through a system to understand how all of these processes and procedures change for the outcome that we have. No, perfect. And then I know you said that for this application, what we're talking about is on SIMCA. Is that the favored? Is that the favored tool for Industrial Insight? Is that one of the tools? Is this the best tool out there?
Well, it's what we learned on. I think it has the best interface, and I think certainly the orthogonal piece seems to work very well. I've talked to, there's a gentleman I'm good friends with who works for one of our customers who's been, he's a, master's degree level statistician, 30 years in the business, and this is all he does, and he evaluated everything. And he said, this is the best tool for us. And, he told me why. He loves the orthogonal component. He feels like it gives him a bit more accuracy. I'm not a statistician. I'm not a math genius. I don't necessarily understand all the mathematics behind it, but are there other products? Yeah, I mean, we've got a customer also testing out Aspen's Pro MB. It's got the same algorithms, just without the orthogonal component. The user interface is slightly different, but it essentially does the same thing. PCA is PCA, PLS is PLS. I mean, that math's been around for a long time. And really, it's about the user interface, the support you get with the product, and, in their case, they have an additional algorithm that, people in industry who seem to know, really like. So for us, Yeah, it's our go-to tool. We know the SIMCA folks well. We think they're very sharp. They've been incredibly, gracious to us with, letting us use the software, and for that, I like to show it off when we get a good story, and that's why you're here today, is because I think we have a pretty cool story that we're gonna talk about.
Jim, can you tell everyone what we're looking at, and what the particular end result looks like, and we can talk a little bit about the problem and how we got there?
Yeah, absolutely. So this is the reason why you came down. This is why I invited you down. You were in the area, which was kind of cool, being in the South in the wintertime.
Yeah, South in the wintertime,
yeah.
90 degrees out.
Better than Buffalo, right?
It's better than snow.
Yeah. So anyway, since you were close and, we had just worked on this problem, I thought it was a really good story, because I think there's a lot of misconception out there, right? We have a lot of people still telling people, oh, just take a bunch of data, store it at half-second rates, throw it to the cloud, let the machine learning algorithm tell you why you can't do this or why this isn't working, let it write back to the PLC, and it's just automagic. And no, I'm not trying to throw shade on people, but that's just not how this works. Not yet. That day is probably going to come, may or may not come in my lifetime, but and there are applications out there. There's applications with SIMCA that they're writing back and changing things. Literally, there's pharmaceutical companies that are running SIMCA online. They built a model, and they're making changes on the fly. There are some pioneering companies that are using AI, machine learning, and doing that, right? It's typically very specific, and there's not very many applications today. It's usually a lot harder, and people have worked really, really hard to get there, right? And I think a lot of people just think it's automagic, which is a term I love to use. They just think, oh, I'm just going to throw a bunch of data at machine learning. It's going to tell me everything I need to know. It's not really how it works. And so I always like to try to set expectations. So what we're going to look at is, this was a quality problem one of our customers was having. And literally, I was having coffee with a fellow from the Global Leadership Summit, which is a great leadership summit I go to almost every year. I think I missed one in the last 5 or 6. And I get this text and said, "Are you in the office?" I'm like, "Well, no. Why?" "Well, we're having this quality problem. This is a highly profitable area for this company. I'm like, we're having this quality problem. We don't really know why. We don't really understand it. And we've done some multivariate work with it, but the guy that's done that got promoted, and he's really not available as much to help. And we need help, now." I said, okay. So as I was coming home, I talked to a few people at the plant, and I'm sorry for the squeaky chair. Just kind of the way things worked out today. So I called a couple people at the plant that he had directed me to, and they kind of gave me a little bit of the nature of the problem. So Ben, Tia, myself, we met with them the next day, and they spent some time talking about what the process is, how it works, because you have to understand that, and basically have a batch process, and then another batch process, and then a couple of continuous processes, and then they do this quality test. Well, actually, there's a couple quality tests in between. And they're trying to get the final quality in this range, these two ranges. One of them is above a certain range, one's below a certain one. And there's a test kind of in between there that they were looking to get right, because if they got that one right, then their final one was going to be good. And so they were kind of explaining how all this worked. And they said, look, we've had some really good months. We felt like we were running really good in August to maybe about mid-September. And then it seems like we had almost a step change where we really couldn't get it under control. And through about, I don't know, maybe October 28th, 29th, they were still struggling with it. Now, interestingly enough, they made some changes in the process on the 30th, which was a Friday. And they've been running better since, okay? Before we did this, okay? And, but one of those was they slowed everything down. So now they're making less product, but they're making it better. So So it's still not necessarily an ideal solution. They still don't necessarily understand, like, well, where do we go wrong? But what, we did this analysis, and then I talked to the production manager. I had somebody talk to him, kind of how did we do? Like, what'd you think? And, he said, well, they knocked it out really quickly, which was good because, I was struggling to get, our person's time. That's number one. Number two is, as is what we typically see when doing these multivariate analyses, is there's stuff we could eliminate quickly, that correlation, not causation, potentially, right? We'll talk a little bit about that here in a minute. There are some things that are going to be really difficult for us to test. And then there's going to be some things that, when we get some time and kind of get to a good spot, we need to test it. And typically what you have to do is do a design of experiments. This is not my area of expertise, but design of experiments is you're going to make very specific changes and make very specific measurements to understand how, like what changed. And you're going to figure out like which variables actually cause the changes in your process. You're kind of bump testing things. And there's a whole methodology and software, and, it's pretty rigid. It's not my area of expertise. And actually, SIMCA has a DOE software, and they could probably talk to you a little bit more about it. But because that was one of the things they asked me, like after we did this, they're like, "Where do we go?" I mean, it almost seems like we need to do a DOE, and I said, "Well, that's typically where people go." And then once you get the DOE and you figure out which variables like really drive the process in one direction or the other, then you can then run an online model, and then basically. If you've seen a lot of like control charts, where you have 2 and 3 sigma limits, and you're trying to keep like 20 parameters all in the chart. Well, in multivariate, you may have all of them inside your limits, but you may be running terrible because it's some combination that if this one's a little bit up and this one's a little bit down and this one's a little bit down and this one's a little bit up, that's a bad combination, and it makes our whole process go bad. So instead of having a bunch of individual charts, the way SIMCA Online, it's more like in a tube. So it's like you got to keep the dot inside the tube. And if the dot goes outside the tube, you can click on it and say, here's what's driving it outside, and you can make the appropriate adjustments. But you do the model, you do the DOE, you figure out and make sure that you understand what drives your process one way or the other, and then you can like deploy an online model. Right? And that's what your user interface that can then become. And so, this is like scratching the surface of what can be done, right? But this is usually the first step in trying to help you understand like what's going on, right? And so, he really said, in effect, it was good, but we didn't necessarily get the silver bullet, which is usually the level of expectation we try to set. We try to tell everybody, if you're expecting us just to throw a bunch of data and it's just going to be magic and it's going to tell you everything you need to fix, what we've seen is it's a lot muddier than that. And that's why your subject matter experts have to be involved, because it's likely not just one thing, because you would have found it if it was just one thing.
Yep.
Right? Otherwise, we wouldn't even be talking about this. And then, so that was kind of the production manager view of it, right? It was good in that we now have a list of things to test. Okay. I asked the subject matter expert, the engineer, who's been running this process for 20 plus years. And I said, hey man, what did you think? I said, we've done it, and then one of your people has done it. And he said, he goes, Jim, I wish we had this 20 years ago.
Right.
Because I used to have to just take a bunch of trends and try to line stuff up and see what was going on and try to figure this out myself. He said, what you've done is take a whole bunch of data and throw it at something, and now you've given me a list of like 10 or 15 things that are driving it. Everything else is not. Now I've got to go do that analysis on those 10 or 15 things when it may be several hundred things, and I'm trying to line all the data up, because this is like a 4, 5, 6 hour process, maybe 8 hours. Right, you got a 2-hour batch here, 2-hour batch there, and a couple of continuous processes that are a couple hours each. Right, it's kind of hard to line all that up and look at it visually. And so he told me, he said, this is highly valuable for me. I wish I had it 20 years ago.
I was going to say, so was there a solution that didn't involve someone pulling all of their hair out under a stack of paper the size of this room 20 years ago? To be able to, no? Okay.
Not really. I mean, you didn't really have the computing power and the data 20 years ago.
Yeah.
Right? That's the reason why this stuff is really kind of in vogue now, is because we have the computing power. The algorithms have been around for years.
Mm-hmm.
You know, a lot of these algorithms have been around, 40, 50, 60 years. But we didn't have the data nor the computing power to really leverage it, right? And now we do. Most machine learning algorithms, from what I've read, are not necessarily new.
Mm-hmm.
Now, some of the deep learning and stuff like that, yeah, that's fairly new stuff. I'm not well versed on that. It's just not my area of expertise. If we ever get into that, I'm going to have to hire people way smarter than me, way more egg-headed than I am about it. But realistically, this stuff's been around a while, but we just couldn't leverage it. And it was funny. He made the comment, and he said, "Look, man, pi is magic." And I think a lot of that goes for a fair number of historians, but I mean, pi I think is the most powerful of them. That's my opinion. But I mean, I think in lots of ways, IP21, Canary, Rockwell, Factory Hawk Historian, which is pi, maybe Wonderware Historian, but I mean, there's some that have pretty decent tools out there that allow you to kind of see what was going on. To me, by far, pi had the best suite of those, right? And he was like, "Man, pi is magic." He said, "This is like a whole nother level."
Mm-hmm.
And he said, "I really wish I had it 20 years ago." And so that's really, I think, it was kind of interesting to hear their two perspectives. I was actually a little surprised that I would have expected him to be more jaded, because I think the day I talked to him, he was 147 days from retirement. Not that he's counting. Not that he's counting.
Are you counting, Jim?
No, I'm not counting. But my thing is you've got 147 days to get all of his expertise.
Right.
The rest that you can find into these kind of things.
That scares me for the end user.
Exactly.
It should scare the end user.
Exactly.
We've talked about this.
And it does, yeah. And I mean, we have a whole host of videos that we've shot talking about SMEs and retirement that we haven't released yet. And we don't even know when this is going to get released, but we're trying to bank some videos here, so that we can kind of talk about them. Here it is, like November 17th. But yeah, I mean, you're right. That's the scary part. We have a lot of subject matter expertise retiring, and we need them to validate some of the stuff we're seeing in these models, because sometimes the younger generation has a harder time, with it. And so, plus, I was given, I think 5 years worth of data here. And realistically, they had made enough changes both in their process and in the equipment and rates and all that stuff that I couldn't compare 2017 to 2020.
That's crazy.
It wouldn't be apples to apples. So, it made it, kind of unique in what we had to do. So, real quick, I wanted to kind of talk with the end in mind. So I want to talk a little bit about like kind of what we saw, and then we'll actually go build it. Okay. So, first of all, we did some classification, and we'll talk through like how we did this, but we classified the batches, we'll just call them batches, into good and bad, right? And it was based on a particular quality score. Above this was good, below that was bad. Okay. And so, what you can see is even on this graph, all the bad stuff's over on the right side for the most part. All the good ones are mostly on the left, right? So, and then what I can actually do is I can actually look at a 3D model of it, and what we're really looking for is, can we separate, this data, into groups that then we can kind of look at and see what's mathematically different between them, right? So, that was kind of one of the things that we did. And then we also actually Ben remembered this one from our training, is he said, we can color these dots by different things. And like one of the things we did was we took, like, they had an airflow measurement and we made the dots bigger with airflow. And what happened was all these little blue dots way down here got huge. And what they validated with us was, hey, we had a problem with that sensor and we replaced it, like end of January.
Okay.
Those weren't really real, right? And so because we were seeing like 7,000 CFM, of air, and like everything else was like, 3,000 to 4,000. So it was literally almost double.
That's
what they were seeing, right? But then I said, why don't we color it by month?
Mm-hmm.
And so that was what was kind of interesting. So I'm going to hover over this and watch kind of this. All right, so there's January. You see the ones on the bottom left light up. February, March, April, May, June. So if you look,
June,
February, March, April.
Yeah.
Everything's kind of grouped together. So what I told them is I'm like, you guys ran pretty close to the same.
Did something really good.
You were pretty close to the same, right? In those 3 months. You didn't change a lot, right? But then by the time you get to May, you're starting to move.
Yeah.
June, you don't have a lot. And what's interesting is they actually had an outage.
Okay.
So they didn't have a lot of batches that they ran.
It's just all over the place.
Yeah, and they're kind of all over the place. And then July, which we found out was actually their best performing month. January and July were actually their best performing months. All left side, kind of bottom left kind of quadrant here, right? Then you get to August.
Look at the movement in August.
Which was still a bunch of August was good.
Yeah.
September was okay.
Okay.
Okay. And then you get to October and they were running terrible. So you see, it kind of moves in like a reverse Z pattern.
Just the amount of movement.
Correct.
Over the course of 10 months.
I showed them this and I said, look, I don't really know your process, but what I can tell is you're not running it the same.
Right?
That's one thing I can say.
It's more than one thing.
I can say for sure. You're not running it the same, right? And so what was interesting is, let me do that by month number. Let's see if I can do the coloring here. Color. I want to do categories 1 to 12 by 11. And apply. Okay. I always have to go remember that. So let's kind of get this thing like moved around. So we're kind of looking at it from the same view, right? So if you look, January's kind of down here, and then they kind of move over this way into, February, March, April. Then they move up this way, for into July and August,
Mm-hmm.
and then they kind of get over this way by October. So you can tell the process has moved. And this is why
much movement.
Yeah, and so the thing is like, this is why I kind of explained it the way I did, where every dot is just a mathematically summed batch in a 3D space.
Mm-hmm.
Right? And then you're comparing that. If they're right next to each other, you pretty much ran them the same. If they're different, if they're in completely different planes, different quadrants, then you ran drastically different. And it's worth looking at what's different, mm-hmm. right? And so, what we were able to do is kind of look at that and help them understand, hey, you're running drastically different throughout the year. Now, the cool thing is if I go back to the good, bad, like I can say, okay, the good I'm going to highlight, the bad I'm going to highlight. So the bad's red,
mm-hmm.
right? Mm. And now I can do a group-to-group comparison, and then I'm going to sort them in an ascending order. And now I can say, all this stuff in the middle basically has almost no contribution. So I'm just gonna hide it. So now I'm down to maybe like 30 variables, mm-hmm. And I could put the variables down here. I'm not going to worry about it right now, but I can hover over them. That's one of their quality parameters. Remember to blur that one out, please. Okay. And then that's that same thing, good or bad, right? And like if I double click on it, you can certainly see there's more red on the top end and more blue on the bottom end, mm-hmm. right? There's a little bit of intermingling, but you can see the good runs and bad runs. The bads are the reds and the blues are the good ones, right? I highlighted that on purpose. And then if we look on the other side, let me see. See, and that was one we ended up taking out. It was a cycle number. This was like a reactor temperature, right? And so like one of the things I showed them, was, let me see if I highlight, let's see if I can get over one of these. Yeah, that was in January. So I was like, you guys made a change in your reactor temperature sometime around April 21st. It wasn't much, like 158 degrees is right here. Now you're up maybe like 160. Okay, and then all of a sudden, here kind of at the end of the scale, it dropped again, right? Interestingly enough, their worst 3 months were February, March, April. Actually, April was their worst month. They steadily degraded over time, and they didn't run much different. Which was like, that's kind of an interesting thought. Well, it looks like maybe one of their reactions was they cranked up the reactor temperature a little bit. And so that was kind of interesting. And then one of the things I told them, like while we were on the phone, is I said, we're seeing a lot of data really start to get squirrely around October 20th. We're seeing, instead of like this kind of steadiness, we're seeing it kind of go up and down. And we saw this in a bunch of different things. And one of the engineers, the one that has moved on to a different job, he was on the phone, because we want to make sure he was available, and he was the one that really did this data set. And I'm going to talk about how important that was here in a minute. But one of the things that he said was he went and looked in their OEE database. And he said, we started having pluggage issues and some other interesting issues on or about October 20th. Which would have explained all of that. But it was very interesting that I could point out, you guys really struggled in that week from like the 20th through about the 29th. And then he was able to correlate that back to, we were having pluggage issues. I think they were all kind of shocked that you could see that.
Right.
Like, hey, something was going weird here, right? You were kind of steady state. Now you've made some changes, kind of like this one. There's a step change on a couple of things in August. There was a couple of different step changes here and there with some of the parameters. But one of the things that I very much showed them in some of the graphs when we first looked at this, we didn't look at all year. We just looked at July 1st through October, end of October, and I told them very definitively was, you're not running close to the same as you were. If you look on all of the, because I took some screenshots of some of these graphs, there was about 15 of them, is where you're running in July is very different than you're running in October. And it was, some were up, some were down. But they had changed over time. Now, which ones are the camels that broke the straw's back, or the straw that broke the camel's back? Camel that broke the straw's back is a little tougher to do.
A little bit.
But the straw that broke the camel's back, right? You have to go figure that out. We don't know. We just know that this stuff's different. There wasn't any one thing you did on or around September 23rd, 24th that seemed to make a big difference. We looked at it from that perspective. We actually did a before and after. Like what did everything look like before that September 23rd date, and what was different after September 26th. So that way we'd have some separation there. But we didn't really see like one thing. There was a myriad of things that had changed over time. If it had been one thing, they would have already found it.
Oh yeah.
Right. And so that's the reason why you kind of get the reaction of, well, we can eliminate some things, we have some things to test, and some of it are going to be really difficult to test. That's the way almost all of these that we've done have been. And that's why I always caution people when you're like, oh, we're just going to throw machine learning at it and it's going to figure it all out. It's going to tell you mathematically what's different. It will. What you then have to go do is say, okay, what of this actually matters?
No, I think that's interesting, and what's surprising is the huge amount of movement that we saw throughout the course of those 10 months, and the relatively small number of movements. Like that last screen, the reactor went from like 158 to 161.
Mm-hmm.
And that's almost nothing. And there were probably a large series of almost nothing things that happened over the course of 10 or 11 months.
But let's put some context around that 161 degrees. That's an average temperature over like a 2 or 3 hour batch.
Mm-hmm.
That can make a big difference.
Mm-hmm.
You know, I remember, you know, early in my career, I was working on a wire winder.
Mm-hmm.
You know, they were making like multi-stranded wire, you know, like Cat5 type cables.
Mm-hmm.
And they said, you know, plus or minus 1 degree on the extruder. Like if it got 2, 3, 4 degrees off, they would definitely see quality problems in their wire. So there are some processes that are very, very sensitive to small changes. I suspect this will be one of them. And so, you know, that is definitely, you know, something that can happen. You know, and so I always love to show this. I borrowed this from, I think, Alex Sudek. You know, he found these, but there's a whole website that comes up with these. I can't remember what it is.
Mm-hmm.
But I mean, think suicides by hanging, strangulation, and suffocation versus the number of lawyers in North Carolina. Almost a 1-to-1 correlation.
Mm-hmm.
They have nothing to do with each other. You know, marriage rate in Mississippi versus per capita consumption of whole milk. You know, money spent on pets versus lawyers in California. They correlate.
They do correlate.
That doesn't mean they're causal. And so I think the reason why you get that reaction from the production manager is there's some stuff like this that you can just eliminate.
Mm-hmm.
And so we always try to set that expectation to say, look, we're going to see things that are not causal.
Mm-hmm.
They're just simply correlation. You have to call BS and we'll take it out of the model.
Yeah.
Right? Or it may give you a secondary clue. Okay, maybe it's not causal, but maybe there's something else that's causing that's causing a problem. Mm-hmm. You know, so it's this really kind of delicate balance between, in this case, we were playing kind of the data scientist role, you know, versus the process engineer role. And I think in a lot of companies, they're kind of struggling with translation between some of this stuff. And the expectations aren't getting set clearly. You know, and I think that's why, you know, why I wanted us to delve into this, because now we at least understand the data scientist role. Mm-hmm. Because there's a thing that I did in the data prep that they call feature engineering. Well, I didn't know that's what that was called. I know it now. Mm-hmm. You know, so like if I'm telling the data scientist, hey, we need to do some feature engineering here, they're going to go, okay, I understand what that is. And then I can go explain to the process people, okay, here's what feature engineering means. Mm-hmm. Like getting the month number, getting good, bad.
Okay.
That's a feature engineering thing, right? And I'll show you how we did that in some of the discussion. But that's kind of what we did was we took all this stuff, we threw it at the wall, and we said, okay, you know, we know when good and bad is happening. What's different? You know, what are those things that are have the greatest contribution to those things, good or bad? And so, you know, that was really, to me, the value, and I think what the process engineer saw is he said, hey, this eliminates a lot of ground here for me, right? And so that's kind of what we did. And I think, you know, I wish it was more conclusive, mm-hmm. but I think there are some things in there that they're going to discover in the coming weeks and months that they're going to look back on this and go, yep, those were the 2 or 3, 4 things that all lined up that contributed to our issues.
Yeah. And I think short of you going on site and going through each of those 10 or 15 various different processes and going through a DOE to see what happens when you make changes, I'm not sure how much, you know, absolute conclusion there possibly can be. I think that exactly. You went from, you know, 400 variables to 15 variables, and from those they can probably cross out a series of them, like
probably half of them.
The sensor. I mean, the sensor went bad. This data,
yeah,
we don't need to look at it, and we can go. And so now they're, you know, half a dozen,
yep.
or so variables, and now they've got a much better idea what that what that looks like and mm-hmm. how to get there, as opposed to
yep.
we've run very poorly. We know that we've run very poorly.
They start,
Yes.
you know,
Let's go
turning
change
the
everything.
knobs, yeah.
Let's go, or like, let's go attempt to figure out what we did in January or July when we did well, and go back to what we think we had everything set as then.
Yeah. Well, and like I said, the thing that I very much pointed out to them is I said, if I look at, you know, all the things on either end of the spectrum, there were definite changes between, this was like my all year, you know, look, but I did a specific July through October look, and you could see where the things had changed over time. And it was a gradual process. It wasn't like, and there was a couple of step changes in there, but not on the dates that you would hope. But at some point they crossed the threshold. All right. And at least now we know what those 10 or 15 things were.
Yep.
Versus a couple hundred of them.
Okay. So we looked at this over the course of about 10 months. Now, should people potentially be looking at, you know, running multivariate analysis, you know, once a week, once a month, having someone pulling in that data, looking at it to see what movements look like? Is it an all the time thing like your OEE calculations, or is it we should look at it, you know, once a month, once a quarter?
It depends. You know, like I told you, there are people that are running these models. Like, you know, I've been told about some pharmaceutical, you know, runs that are happening. They don't even do final product testing, you know, like lab testing. Because if they run inside the tube in SIMCA Online, they're going to nail final quality because they've done the DOEs, they've done everything they know. If we run in the tube, we're going to make good product. For those that are not in that space, I think it's kind of on an as needed basis. You know, and I think these guys are going to have to figure out, where do we go from here? I mean, this is a really profitable product area. Do we go ahead and bite the bullet and do the DOEs and potentially make some bad product here and there to learn more about what makes us good, and then go make, you know, and SIMCA Online is expensive. It's not a cheap product, right? As you wouldn't expect it to be. But should we go ahead and, you know, but it pales in comparison to what they're making on this process, right? So it may be very much worth it. For others, maybe not. You know, I think it depends. So, is that a nebulous enough answer for you? Gray area? Did I leave enough gray area in there?
I mean, I think there's only gray area in there, Jim.
I think there is. There is no black and white with that.
Okay.
I wish I could tell you there's a black and white, but it just depends.
So somewhere probably above a couple $100,000 a month you're making in profit, you know, all the way up to $100 million a month. It probably makes sense to look much closer at this. But if you're making, you know, negative $10 a barrel on a barrel of oil at the moment, then it probably doesn't make sense to spend the money looking at SIMCA Online.
Well, if you're making minus $10 a barrel and you should be making $50 a barrel, then you should look at it, right? I think there's a lot of manufacturers that their margins are so thin, you know, that maybe it doesn't make sense, but there's a whole lot of processes. I mean, this is millions of dollars.
Oh, yeah.
And SIMCA Online's tens of thousands. I mean, you decide, right?
Yeah.
I mean, do you want to go spend tens of thousands? And, you know, it's not just the tens of thousands, but it's also, you got to do the DOE testing. You got to have the software for that. You got to have people that are trained in that. You've got to actually go do it. And that takes time and time away from things. So there's a lot more cost involved. I mean, it may cost you, you know, $250,000, $250,000 to run all the testing you need to know where you need to run. Then you invest the tens of thousands in SIMCA Online, or potentially hundreds of thousands, depending on how complex it is. But if you're making millions and could make more and could do it all the time, then it's probably worth it. And most of the companies we deal with, it's not hard to find $1 million problem somewhere, right? And, you know, but the thing is, you have to have the right expectations. Sometimes it's really muddy. Like, I've done some of these analyses. I looked at, we had a paper customer that was having an apparent density problem. I never found anything conclusive. And I looked at it from a bunch of different angles. I looked back through their pulp mill, lined up the pulp mill data, you know, I kind of validated, you know, the time lags, and I didn't find anything conclusive. There was a couple of things that looked like maybe that could be a cause, but I was almost convinced, I'm not sure you have all the data you need. We don't know what your real chip quality is coming in. You know, like we don't know if you were cutting fresh chips or if this is month old sitting on the pile and been rained on 30 times. We don't know. Right? So sometimes it's a lot muddier than you think. You know, and we did that one pro bono. I just said, look, I want practice at this. If we find something conclusive, we'll work out a bill. If not, you don't owe me anything. Because we wanted to get better at using the tool. We never found anything conclusive. I wish we did. And so that's why I always try to set that expectation that we're going to eliminate ground. Correlation is not causation. But hopefully we find some things that make sense. Well, and what was interesting is we actually did an analysis, right? Their best months were January and July. And then I had a little bit of data for November. I think I had some stuff for November 1st or something like that. But you look, remember we looked and they ran very, very similarly February, March, April, right? What was interesting is this quality parameter steadily decreased and this one steadily increased, which went, was poor and went poorer, and this was good and went worse. They didn't really change much. Which I'm almost like, well, what changed on your feedstock coming in? Were there other things that we're not looking at that changed it?
Maybe environmentals.
Could be environmental. We don't know, right? But what I could definitively say was July was your best month. October was almost as bad as it got. And I saw drastic differences between July and October. And we saw drastic differences, all through the months. You didn't really stay the same.
What'll be wild is if when it gets cooler in December and back to January, if they haven't figured out the issue, and then the data quality goes similar, or the quality of the outputs goes similar to what we see.
Well, one thing that is interesting is in one of the operations, they do know the ambient temperature does have an effect because they have to pull more air. Because they're heating it up and they need more air. They need more air. I think I remember them very distinctly saying ambient air does affect it. We do need to pull more air when it gets cooler out. And, it'd be interesting to see, but we don't have the readings. Like I even thought about throwing weather data at this, just going and getting the local weather station daily average high and low and throwing it at it and saying, does that seem to matter? But I think we could see it in the seasonal. I think we could probably make enough inference there that, that we could see that. I wanted to talk about that because nobody wants to talk about that. Everybody wants to sell you something. Everybody wants to sell you their cool machine learning algorithm and it's going to solve all your problems and you're going to make millions of dollars. But nobody wants to talk about the ugly side where you may not have all the data you need. You guys hear me and Dave talk about data quality. This is why. If you don't have good data quality, which we did here, then you're going to have junk for results.
Yep.
Right? And so those are things that I think so many people miss, and they just want to go. They want the silver bullet. They want the easy button.
We would like that as well, right?
It's like I want to go lose 20 pounds, right? You just give me a pill.
Yep.
And give me a pill that I can have a washboard stomach, and all the energy that I would ever need, and nothing hurts. And I want to be built like Schwarzenegger back in his prime, and I'm 50. There is no pill for that. If I want to get my butt in the gym and go work out like crazy, eat right, and do all those things, nobody wants to talk about that though in this space. Everybody wants the easy button, and that's why I wanted to at least kind of go through this to say, hey, look, we found some things that were quite interesting, and we're able to show them like, hey, you're not running the same.
Mm-hmm.
You're not very disciplined in how you're running your process.
But people don't want to talk about that.
People don't want to talk about that part, right?
Lots of engineers and SMEs know that that's the issue, and every operator likes to turn the dials when they come in on the shifts.
And one thing is this wasn't even operator specific.
Oh, yeah.
We looked at that. We did a color by operator, and it looked like a kaleidoscope.
I'm sure that would have been a lot of fun.
There was stuff everywhere. It was great, Like I think I can even do that pretty quick. It was hilarious.
I've gone so far as to talk about putting biometrics on machines so operators can't change.
Yeah.
Oh my goodness.
There's the crew at start. So we have grays missing, and then you have A, B, C, and D. So it didn't matter. The crew didn't matter.
We've still got a very similar pattern.
Well, the pattern doesn't change. All I'm doing is just changing the color.
No, I understand, but I'm not saying it's not like C ran well the whole time. It's not like one person has figured it out. And I have found that in every space, everyone likes to tweak it their own way.
No doubt.
But no one has it figured out.
Well, and not only that, that's what makes the model so dang muddy. Mm-hmm. Right? And that's why I just kind of shake my head when somebody's like, oh, we're just going to throw all your data, like why your OE's not where it needs to be. We're just going to pump all your data to the cloud. Mm-hmm. It's going to go figure out why your OE's down, and it's going to make the changes in the PLC. Well, maybe one day, but the model's really muddy because we don't have this stuff down to a science. There's still too many people that think all manufacturing, whatever they make, is an art.
Oh yeah.
And they don't think it's a science. I mean, I've had that discussion with whiskey manufacturers. I've had that discussion with paper manufacturers. They think it's an art. No, there's a science as to why your paper is not of the right quality or why your whiskey doesn't taste the way you want. Mm-hmm. It's a science. There's a chemistry to it. And you haven't figured it out yet. And, that's the part that people don't want to hear. Mm-hmm. They just want to sell you some software. I'm not going to hide from the fact that, look, this is going to be hard. I may not even find anything for you. I hope I do. I hope I give you some clues. Mm-hmm. But I may not. Are you okay with that? Because too many people want to just sell you a piece of software and like, oh, we're going to solve all your problems. No problem.
I don't know many people that, from a manufacturing perspective, that someone could say, I'm going to sell you this piece of software, it'll solve everything, and they wouldn't be laughed out of the room. I mean, how many times do you hear that?
How many times have people bought stuff? You and I both know stories where people have bought things.
Oh, lots of money.
There's tons of money been spent in this space, and people are disillusioned, disenchanted about it. And I'm just determined that we're going to approach this differently. Mm-hmm. Look, I'm going to tell you, hey, this is what I think we can do. It may not be crystal clear. I hope it is, but it may not be. So but I think this is a great story because we could definitely see some things. I thought what was very interesting is we could say from July, which was your best running time, till October, here are 15 things that are drastically different. Mm-hmm. We don't even know your process, and we found these like that, basically. Mm-hmm. Like that was one thing that we found. Two was we found you ran very differently month to month. I showed you that.
Still crazy.
Right? We saw something really weird happen around October 20th. Mm-hmm. And they validated that. So three things. We know very little about this process. But we were able to tell them three very definitive things that they went, yep, you're right. Mm-hmm. Huh. Even though we didn't necessarily, we may or may not have found the problem or the things. I would be willing to bet that the answer lies in this somewhere, in those 10 or 15 things.
And time will tell.
Time will tell. But I just thought it was interesting that those three things were very definitive.